So yes, my name is Nagy, and as I told, I'm based in Budapest in Hungary, and I'm part of the product management team, which is responsible for enterprise Java Cloud development. Mostly, I'm working on WebLogic, Coherence, and the Helidon project. Okay. So this is a slide what we need to always contain in any presentation, since we are Oracle, and especially in this case it's much more important because I'm going to talk about such projects which is Project Loom, which is really not yet available. This is clearly an experimental feature at this moment, and everything can change in the functionality of Project Loom. But this is a really promising project, and I hope sooner and not later it will be included in the one of the JDK LTS release. Okay, so this is me. So let's get started. Before I jump into the details, let me tell you, I would like to, this presentation, make it as interactive as possible. So feel free to stop me, make a question through the Q&A, and I'm trying to answer to that. Okay, so why Project Loom? Okay, maybe some of you have heard about that already, but if not, it can be pretty new for you. Okay, so it was something like started 2 years ago or 3 years ago. And the reason is why that to building a responsiveness application is always a never-ending story. Okay, so we have more and more and better techniques, obviously, and architecture changes like microservices architecture. But usually, when we need to write an application, it needs to be really responsiveness in certain cases. Even if we have, for example, microservices architecture, we can't leverage on the fact that we can easily scale using, for example, a container scheduler or application, because think of it, that still requires time. Okay, even if we have much more better technologies and also methodologies like functions, so we can really quickly start up certain applications to respond to requests. We need to ensure that the application itself, even if it's a tiny microservices application piece, that can scale properly to the needs. Okay, some of you can say that it's pretty impossible with Java. Some of you can say it's possible, and I'm belonging to that group, so it's possible with Java. We know Java is a pretty old language in one term, but it is evolving really rapidly, and a lot of modernization is happening continuously, and you can see the result. Okay, so for example, one of them is, which is nowadays a really hot topic, and we also apply in our Helidon microservices framework, the native image graph, native image, where you can also can get a really high step in case of performance and startup time and less resource requirement. Okay, so what's basically the problem around not just Java, but in generally when you write an application? So the problem is around the concurrency and the blocking calls. Okay, so these are going hand in hand. So the problem is that obviously we need concurrency, because our application is used by many other users or many other applications in the same time. So we need to serve requests concurrently at a given moment. Okay, but during the completion of the request, we can have certain steps, certain functions, which will stop for a moment. So we have blocking parts in that completion. Okay, and this introduced the problem that our application can't scale really quickly and can't really complete the request in a way how we would like to. Okay, and basically, we have threads for better scalability. This thread is really not a new thing. So if you are such old as me, then you remember, okay, sometimes before 2000 there were computers with only just one core. Okay, but even that time the threads was already introduced, and a couple of operating system and runtime environment already introduced the thread to enable the multitasking. Okay, but it became really powerful when the hardware started to be able to serve more thread execution using the multiple cores, multiple thread management, okay? And from that time, also operating system also started to support, obviously, because operating system is responsible to offer the hardware resources for the user application. Okay, so the operating system manage the thread execution from the beginning, since we have the possibility in the hardware. Okay, but there are quite few problems with this. Okay, so operating system threads must support all use cases and programming languages. Okay, so this means that is a very low optimization for specific runtime. So for example, for Java or any other runtime environment, because that is a generic solution from the operating perspective, how the operating system schedule the threads, how switching the context between them. Okay, the result, how the OS nowadays manage the threads, finally, it's pretty heavy weight, okay, because it requires pretty much resource to store all the information to a certain thread, okay, and also quite expensive to switching the thread on the core. When we're talking about this is expensive, what does it mean? That basically the CPU not really working during this time when switching the context, so we are losing resources, okay? So that takes a lot of time, okay? And obviously we have a limited numbers of threads, and this is typically something like few hundred on a regular hardware. Okay, threads already available in Java since Java 1.2, and the basic idea behind the Java implementation, that the Java line thread is wrapped in and mapped into a native operating system thread. Okay, so whenever you create a new thread in Java, that is mapped to an operating system thread. Okay. So the problem again, whenever you start to execute a thread, and especially more thread, because you are going to serve multiple requests at the same time, and you are opening more thread to complete this concurrent task, the blocking calls. Okay, so whenever your competition stage reach a certain point, so for example, calling an external device like network card or disk, or it needs to retrieve some data from some slow backend like database, then it will block the thread for that moment, okay? Which costs a lot, okay? Even if we can switch the threads, that also takes some time, and that also costs a lot, okay? So the operating system can suspend the thread, as you can see, until the result of the operation is available. But if you do a really short math, then you can see that if we have something like 500 requests per sec, and okay, we have a pretty slow backend or blocking, which takes 2 sec to respond in a certain task, that requires at least 1,000 threads on average at a given moment, okay? And also, if you calculate how many memory required to maintain those data, which is associated with that thread, it's 1,000 megabytes, which is 1 gigabyte just for metadata, okay? So this is the problem with the thread execution. What we can do to solve this issue? So one of the solutions to make non-blocking calls, okay, we can do it on operating system level. So for example, to the networking, to the disk, but it can have certain problems, and this solves only just one single problem. So if we have a task which involves a lot of other resources, the disk, network, even if we solve just the network part or the disk part, the other will block our execution, and the application will not be scalable. Okay, there can be an operating system independent solution on top of the operating system. This is like the Java Neo. I think most of you are aware, and we are using nowadays this solution. So for example, one of the good examples for this, the Nagy web server, where this abstraction layer solves the non-blocking I/O access to the HTTP request. Okay. The other solution, the event-based execution model, or we can say reactive programming model or asynchronous programming model. So you can love it or hate it. I belong to the hater group, basically, because it requires a really different approach to your program. And especially it can be hard and tough when you have an existing program, what you want to make scalable. And this means there are a lot of things what you need to, for example, migrate, rewrite to make it asynchronous compatible. Okay, so in theory, at this solution, there is a dedicated thread. This is the event loop, which looks through all the tasks and are assigning to workers. Okay, what is good here, we have basically no context switching, but we have another complexity, as I told you. So you need to manage asynchronous operations. You need to deal with callbacks or many ways of future implementations, or you can introduce async await, which makes kind of synchronized programming model. This is not available by default, I mean built in the JDK, but there are a couple of third-party libraries which allows you to use a synchronous programming model in a synchronous way in your program. Again, it looks like synchronous, but still asynchronous. Okay, and also, it introduced another complexity, for example, with the debugging as well. So if you have tried debug asynchronous code, then it can be much more complicated, like in case of a synchronous world. Okay, and also other problems with the asynchronous approach, as I told you, if you have an existing application, so not a completely new application, then it can break a lot of old interfaces in your application, which needs to be rewrite. And we know it's hard. So we have an application in production running. It's hard to change the whole one, even if we just want to introduce a small module. Okay. And again, it's hard to go from the synchronous world, the synchronous thinking to the asynchronous world. Okay, if you have tried, you know what I'm saying. So it's pretty hard to change your mind at the beginning. Okay. So basically, you need to choose between these two approaches. So still you can have the traditional simple blocking synchronous approach, and you can somehow fine-tune the thread pool, the thread numbers and stuff like that. And you can pay attention more, focus on certain part of your code, which is really blocking your competition. But this will be still less scalable, okay? Or you can use the new approach, the complex asynchronous approach, but this can break your legacy application, and the code, and obviously requires a different mindset. But on the other hand, you will get a scalable code. So this is where Project Loom comes into the picture. Okay, they introduced the fiber. Okay, we can say fiber is something like a lightweight thread, a virtual thread, or green thread. Again, if you are such as old as me, then you can remember a green thread concept is not new. Green thread, this concept was introduced in the JDK 1.2, and it was for Solaris, where JVM tried to solve the thread scheduling problem and the thread switching problem in the JVM level. But later then, after the 1.2.0, it was deprecated and removed from the JVM. And now, in a certain way, we also putting that together with Project Loom. There are some differences, but more or less the concept is the same. Okay, so what does it mean for us? Okay, so this is a lightweight thread because it is in the JVM, okay, close to our program, close to our applications. And this is really lightweight. So there is no such metadata requirements like in the operating system thread. So you can have almost millions of them. Okay, I haven't tested such capacity, but during a couple of load tests, I could see the scale around 100,000. Okay, so it is managed by the Java virtual machine, so it is part of the JVM, the JDK. They are trying to introduce in a way that to use the existing APIs. It's really important. Again, if you have already an application, what you want to make, what you need to make more scalable, it's much easier to introduce. Okay, if your application is still running on Java 8 or some older version of Java, then you can't escape from the migration phase, but still it can be much more easier probably than completely rewrite your application in an asynchronous way. Okay, so what is Fiber? Lightweight thread, and basically it includes two things: the continuation, basically continuation of the task itself, okay, which can be suspended. That is really important, okay, because this is necessary for the performant, efficient thread management, okay. And the other part, the scheduler, obviously. So we need to schedule somehow those threads, those lightweight threads, okay. At this moment, there is no plan, but maybe later you can have your own scheduler, for example. So there are such ideas as well, but at this moment, the scheduler is provided. And basically, it is based on the forward join pool approach. Okay, and what is much more important here, that using Fiber, it enables non-blocking code to be synchronous, virtual thread synchronous. So again, you still can use the good old approach to develop your application, and you will get all the benefits, I mean performance benefits, what you can get if you switch to the asynchronous reactive way. Okay. There are a couple of temporary and permanent limitations in the current implementation, and there is still no final date, I mean, which LTS release will include Project Loom. However, it is already available, so I'm going to show immediately my test results. So the JDK 16 has a version which includes Loom. You need to download it separately, and you can already try it and test it. And I think it works. So if you have time and you are thinking about, how to make your current application more scalable, it's worth to take a look with the fibers, because you will see immediately in certain cases, you really don't need to change too much in your existing code, okay? Okay, a couple of words about Project Helidon, but as Marco told, you heard about yesterday. So I'm trying to be pretty quick and just run through for those who haven't heard about Project Helidon. Okay, so Project Helidon is basically a microservices framework from Oracle, and it gives two flavor of programming style. So basically we have a Netty core, and on top of that we have the Helidon core. It's called Helidon SC. So using Helidon SC, you can write a really fast, performant microservice application, which requires really small resources. Helidon SC provides a functional style API, so there is no such kind of magic behind the scenes like CDI or dependency injections. Okay, so that is much more closer to the traditional Java SC application, which allows much more control and flexibility in this case. On top of that, we have implemented the microprofile specification. Okay, and in this case, if you use the Helidon MP version, it's getting a bit more complex because of the CDI and stuff like that, but you can get much more easier declarative way of programming style. And especially if you are coming from the Java world, that is much more familiar to you. So it's much more easier to learn how to write microservices application, okay? Obviously, on top of that, your application is running using the underlying infrastructure and interfaces. And we already provide extensions based on the CDI extensions. But if you already use some CDI CDI supported third-party libraries, it's easy to integrate immediately with Helidon MP using the CDI extension. A couple of words about microprofile, if you haven't heard about that, but I think it's getting more and more popular nowadays. So whenever you write your microservices application, we are talking about the Java application development, you need some certain set of functionality. Okay, so because you want to focus on your business logic. Okay, whenever you write your microservice application, it is somehow similar to the Java EE word. So you don't want to really care about what kind of how to solve the persistence to a database, how to solve the transaction handling, the management, and stuff like that. And this is what this microprofile spec provides for you. So if you choose such runtime, which implements the microprofile spec, you will get a mandatory, I would say, a mandatory set of feature which is necessary for microservices application. A couple of them, okay? So configuration, obviously one of the most important whenever you write any application, not just a microservices application. Health check, it's important for a container scheduler because you are going to package your application in a container and you will run on a container scheduler like Kubernetes. Then that system needs to know whether your application is up and running. And this is where health check can help. Okay, you need metrics. So metrics by default part of the application development. So no need to think about later what kind of diagnostic management tool you will introduce and adding some agent or instrument your code and stuff like that. No, metrics are already available. You can easily extend the metrics, the basic metrics, to have your own metrics, and then you can see any information on your dashboard what you want to see about your microservice applications. Fault tolerance, crucial part. GWT propagation, like security. Okay, so again, what you can get here if you choose runtime which implements microprofile spec, that a set of feature which is necessary to write a proper microservices application. Okay, how it looks like if you use the Helidon SE, you can see on the left side both codes doing the same. So this is a simple Hello World REST endpoint. So on the left side, you can see the Helidon core API. So it's a kind of functional style. There is no magic. Like on the right side, you can see there is annotation, a declarative style programming model. And if you're familiar with Java EE, you can recognize this as JogService. Okay, so how easy to decorate an existing method, a class, and you will get immediately a REST endpoint. Okay. Here are the features what we are providing for Helidon SE and for Helidon MP. I'm not going to do details. You will have the presentation and you will find more information on the Helidon side. What I would like to highlight, if we are talking about scalable applications, the build profiles. So Helidon supports, obviously, the default executable jar packaging, which means we have a jar which needs to be run on a Java runtime environment. So that's all. No need any other, for example, applications that were like in Java EE world. You can have also the J-Link option. So we support the J-Link packaging where we are creating a customized Java runtime environment for your application. So reduce the size of the Java runtime environment. We just pack those modules into the container, which is necessary for your application. Okay, J-Link is part of the JDK, so this is nothing, something new is introduced by Helidon. And what is exciting here is the GraphVM native image. So if your framework or support a native image, then you can get a lot of performance gain. So for example, you will have less memory footprint, less image size, and much faster startup time. If you are not familiar with GraphVM native image, just Google it. I'm not going to the details now, but basically the idea is using the just-in-time compiler, then we can take the whole Java application itself and compile into executable native binary image, okay, which runs directly on the operating system. And portability is not an issue anymore since we are packaging our application into containers, okay? There are a lot of trade-offs if you're using native image, so you need to decide whether you want to go with that, but in certain cases it's worth. So if you think of the startup time, then you can easily implement functional style of application, which need to be just start when the request comes in, okay? Obviously, this doesn't solve the threading problem. So this is another approach to solve another problems like startup time, memory usage, and stuff like that. But this obviously doesn't solve the thread problems. Okay, more informations here about Helidon. And let's see how we try to introduce Project Loom in Helidon as an experimental feature. At this moment, the virtual thread is not yet available officially in any Helidon release. If you want to do, there is a branch available. Helidon is an open source project, so there is a branch available on Helidon. You need to build your own Helidon binaries. So this is not available in the Maven repository because every hour release available in the public Maven repository. So if you want to try it, you need to build your own Helidon binary using the JDK16, which contains the Loom, okay, the Project Loom, the fibers, and then you can start to test it, or even just you can start your test with your application, the Project Loom. Okay, what was really interesting, again, this is just an experimental phase, so we didn't really heavily tested this thing, but the results are impressive. So we had to change 3 files only so far. Okay, 2 of them basically a Java class about how we can create executor for the request for the native, and the one was the pom.xml to include, the 16 version in our project. Okay, first you need to get the JDK, as I told, which includes fibers. There you can see the URL. So if you want to try that, you can go there and download the proper version, which is necessary for your operating system. Again, keep in mind, this is not for production, and functionality is subject to change. Okay. Okay, here we have our test application. I use Helidon MP, so this is the declarative style of programming and development. What you can see here is just basically a sleep service, a sleep endpoint, and what it does, by default, it will sleep for 100 milliseconds. Okay, this will simulate somehow the blocking call. Okay, so whenever a request comes in, there's a blocking call during the competition, but obviously another and more requests are coming during the block. Okay, so I'm using a pretty simple and powerful load test tool, which is Vegeta, and obviously, since we are talking about Java, I'm doing a warm-up before every test. I mean, every time before I record the data. I mean, heap size, thread pool size, and stuff like that. Okay, this is a fairly small test. Okay, the Vegeta will provide 1,000 requests per sec. Okay, the duration will be only 10 sec. This is done. This test was executed on my laptop, which is pretty old, a 4-core MacBook, but a pretty old one. So I didn't want to really break my computer, because that can also influence the proper result. Okay, but that was enough to see the real differences. Okay. I use JConsole to monitor the threads and also the heap size. And there are 3 scenarios. So the first one is the default configuration of Helidon. You can fine-tune Helidon, but there's a default configuration for Helidon. Oh, that is wrong here. Okay, the default one, starting number of thread is 8, not 16. I need to fix this. Okay, so by default, yeah, and this default is only true for my computer, because the default value is calculated based on the available CPU and thread number, and in my case it's 8. Okay, so before I start the test, I will have 8 native threads in my application. Okay, the second scenario will use the virtual threads. And the third scenario, we'll use 100 native threads. So I was just curious to somehow roughly tune our application and make immediately 100 native threads available, which means they don't need to create new threads. However, this makes much more context switching, but I was curious how it will work. Okay, so let's see the first one. Okay, some problem with the control bars and the videos. Okay, so let me put it here. Okay, so this is the initial default one with the native threads. There you can see the initial heap size, something like 20 megabytes. All the memory is something like 55. And we have 23 threads. If you're familiar with Java, you know there are a lot more other threads necessary to run a Java application, the JVM itself. Okay, so for example, there is one thread for garbage collection, there is one thread for GMX server connection and stuff like that. So basically the number of the worker threads, what you can see here, and named with Helidon and some numbers. So there are 8 what we have to complete our requests. Okay, so let's see the result. After the test, we will end up something like 200 megabytes, and the heap size from this 200 megabyte is more than 100 megabytes. And there you can see the live threads went up to 52. And what is interesting for us, the number of worker threads, so it was scaled up to 32 threads. Okay, so again, this is a really short test, but that resulted such reaction from our application to serve the request, to complete the request. Okay, how it looks like, the response time. So there you can see at the beginning, the latency was pretty slow and getting higher and higher as we are creating more and more requests against the application. And there you can see at the end of the day, it ends up something like 7-second response time, which is not so good. Okay, so I wouldn't say this is a responsive application, especially it will hang on this level. Okay, after there you can see, so what is the distribution of the response time, and almost the half was above 2 sec, and we can see on the diagram this. So this I wouldn't say this is a really performant, and this is just a Hello World application with a really powerful netty. Okay, so let's switch to the virtual threads. Okay, now I have built my now I have my built already pre-built Helidon libraries with virtual thread, and I'm using in this case those. Okay, initially we have almost the same live threads. Okay, almost the same memory consumption like in the previous case. But what is interesting here, we don't have any more our worker thread, which is maintained by the Helidon. So what you could see previously as a Helidon 1, 2, 3, and stuff like that. There you can see the 4-join pool. Okay, so based on the 4-join pool approach, the Project Loom provides the worker threads. Okay, so you are not going to create and manage anymore that thread pool. Okay, let's see what happened after the test. Okay, memory goes up something like 90 megabyte. The heap size itself less than 40 megabyte. And the live threads goes up to 25. Unfortunately, I did the screenshot later than I wanted, and the worker 7 node is disappeared. Okay, which means we had 7 worker threads. Okay, compared to the previous 32. Okay, but again, the 32 Helidon threads in the thread pool was mapped one by one to native threads, okay, to an OS native thread. But here we have only 7, which is a lightweight thread, and that is not mapped to a native thread, okay. Oh, sorry, that is mapped to the native threads, sorry, only 7. And here you can see the response, okay, response time, and this is much better, even if we have some peak, but those peak under 200 millisecond. So there's no second here, okay, to completing the request. And again, we have just changed 2 classes in our Helidon framework, which is now using virtual thread instead of our thread management, okay. And there you can see the the distribution. So the majority of the answer below 100 millisecond. And the third one, which was also an interesting one. So the memory usage at the beginning almost the same, but we have already 120 live threads for the whole Java application. So we have 100 native threads maintained by the thread pool, the executor service in Helidon. And the other terms, obviously we didn't, I mean, Helidon didn't increase the thread pool size because it was enough to serve the request, but the question is how fast was this the thread pool, how the thread pool could serve really the competition. And this wasn't really good. So we are still under 200 millisecond, but there are too many peak here, but obviously much better compared to the default initial size of thread pool size. So this is what I can say. This is a kind of thread pool and thread tuning at this point. But think of it, this is just one instance of your microservices application. And if this consumes something like 100 threads or maybe less, 50, so you can end the tuning with 50 thread in the thread pool, which is continuously exist. Okay, so that is lives in the thread pool, and that is only one application instance, and you are going to run your microservice application multiple instances, and that is only one part of your microservice architecture, which is running maybe on the same node on Kubernetes. And again, we have fairly limited numbers of operating threads, even if, okay, containers hiding, and there are a couple of others, mapping techniques and stuff like that. But at the end of the day, we will not have enough native threads in our environment. Okay, and again, even if we had 100 threads in the pool, we couldn't perform better than the virtual threads with 7 native OS threads. Okay. Yeah, so still you can see the distribution is much better compared to default thread management, but still worse than the virtual thread. Okay, so what is the conclusion for this? Basically, virtual thread clearly won this test case. Obviously, this is really synthetic. I mean, so I have just created a very simple sleep service. Obviously, you need to test your own environment, your requirements, your application, which can have different results. Maybe virtual thread can't deal with your needs. Okay, but what we can tell you, the code impact was minimal. So you can go to GitHub, you can check what we have changed, and this was really a few lines of code, and immediately we can utilize the benefit of the virtual threads. What you can see here, the virtual threads are cheap, so the memory consumption was really low also to creating and switching between the threads. So the heap was almost as low as the beginning. Okay, and you can still write your synchronous code. Okay, so you don't need to switch to the asynchronous world. You can do if you want, but if you don't want and you are looking for an alternative solution, this can be a solution. Obviously, the problem is this is not yet available for production, but hopefully it will be soon. Okay. Okay, thank you very much. Any questions so far? What wasn't clear? What was confusing? Or I'm opening the Q&A. You can post your question there, or you can use your mic. Okay, I can't create a poll, but I would be curious about how many of you are already using asynchronous programming. If anyone, please just post a yes or something like that in a Q&A or a chat. So how many of you would wait for this just to keep the synchronous approach. Okay. No,
Hi, Peter, but I think it's still a sleepy morning here.
No worry. There is one question.
Yeah.
Are there any approximate estimation of when the Project Loom is going to get integrated into OpenJDK? Yeah, so again, it's already integrated in JDK 16, so you have a version what you can try. Obviously, there is very limited version. I mean, if you have a problem and there is another JDK 16 out there with other patches, and maybe Loom will not be included. So Loom specifically included only one version of OpenJDK, which is the major release 16. Okay, I don't know. Frankly speaking, I don't know any date, and also I would refer to my safe harbor statement. So based on this, you wouldn't do a really big decision, but I really encourage you to try it. And the JDK team is always happy to get feedback about projects. So your voice matters.
So the answer would be probably in 16?
Yes, I would say. And that will be an LTS release, as far as I remember, which means that we'll get a long-term support window.
Any more questions? Anyone maybe?
Cool. Many thanks for the opportunity.
Thank you, Peter. It was a great session. Thank you very much. And we now have a few minute pause until the next session, which will be at 9:55.
Grab a coffee.
See you later.
Thank you. Bye.